Number theory. Number theory is concerned with the properties of numbers in general and in particular integers. As this is a huge issue, we decide to divide it into smaller topics. GMAT is dealing only with real numbers, which include integers, fractions, and irrational numbers. Integers. Integers are defined as all negative natural numbers, minus infinity to minus 1, 0, and positive natural numbers, 1 to infinity. Note that integers do not include decimals or fractions, just whole numbers. An even number is an integer that is evenly divisible by 2, that is divisible by 2 without a remainder. An odd number is an integer that is not evenly divisible by 2. Even number is of the form n equal to 2k. Odd number is of the form n is equal to 2k plus 1, where k is an integer. 0 is an even number. Coming to addition and subtraction rules, we have even plus or minus even is equal to even. Even plus or minus odd is equal to odd. Even plus or minus odd is equal to even. Coming to multiplication, even into even is equal to even. Even into odd is equal to even. Odd into odd is equal to odd. Division of two integers can result into an even or odd integer or a fraction. Irrational numbers. Fractions, also known as rational numbers, can be written as terminating or repeating decimals such as 0.5, 0.76, or 0.333, so on. On the other hand, all those numbers that can be written as non-terminating, non-repeating decimals are non-rational. So they are called the irrationals. Examples would be root 2 or the number pi. The rational and the irrationals are two totally separate number types. There is no overlap. Putting these two major classifications, the rational numbers and the irrational, together in one set gives you the real numbers. Positive and negative numbers. A positive number is a real number that is greater than 0. A negative number is a real number that is smaller than 0. Coming to the rules, 0 is not positive, not negative. And multiplication, positive into positive gives positive, positive into negative gives negative, negative into negative gives positive. Division, positive by positive gives positive, positive by negative gives negative, negative by negative gives positive. Prime numbers. A prime number is a natural number with exactly two distinct natural number divisors, 1 and itself. Otherwise, a number is called a composite number. Therefore, 1 is not a prime, since it has only one divisor, namely 1. A number n greater than 1 is prime if it cannot be written as a product of two factors a and b, both of which are greater than 1. N is equal to ab. Only positive numbers can be primes, and there are infinitely many prime numbers. The only even prime number is 2, since any larger even number is divisible by 2. Also, 2 is the smallest prime. All prime numbers except 2 and 5 end in 1, 3, 7, or 9. Since numbers ending in 0, 2, 4, 6, or 8 are multiples of 2, and numbers ending in 0 or 5 are multiples of 5. Similarly, all prime numbers above 3 are of the form 6n minus 1 or 6n plus 1 because all other numbers are divisible by 2 or 3. Any non-zero natural number n can be factored into primes, written as a product of primes or powers of primes. Moreover, this factorization is unique except for a possible reordering of the factors. Prime factorization. Every positive integer greater than 1 can be written as a product of one or more prime integers in a way which is unique. For instance, integer n with three unique prime factors a, b, and c can be expressed as n is equal to a power p into b power q into c power R, where P, Q, and R are powers of A, B, and C respectively, and are greater than or equal to 1. Verifying the primality of a given number n can be done by trial division, that is to say, dividing n by all integer numbers smaller than root n, thereby checking whether n is a multiple of m less than root n. Example, verifying the primality of 161. Root 161 is little less than 13. From integers from 2 to 13, 161 is divisible by 7. Hence, 161 is not prime. If n is a positive integer greater than 1, then there is always a prime number p such that n less than p less than 2n. Factors. A divisor of an integer n, also called a factor of n, is an integer which evenly divides n without leaving a remainder. In general, it is said m is a factor of n for non-zero integers m and n if there exists an integer k such that n is equal to km. 1 and minus 1 are divisors of every integer. Every integer is a divisor of itself. Every integer is a divisor of 0 except by convention 0 itself. Numbers divisible by 2 are called even and numbers not divisible by 2 are called odd. A positive divisor of n, which is different from n, is called a proper divisor. An integer n greater than 1, whose only proper divisor is 1, is called a prime number. Equivalently, one would say that a prime number is one which has exactly two factors, 1 and itself. Any positive divisor of n is a product of prime divisors of n raised to some power. If a number equals the sum of its proper divisors, it is said to be a perfect number. Example, the proper divisors of 6 are 1, 2, and 3. So 1 plus 2 plus 3 is equal to 6. 6 is a perfect number. There are some elementary rules. If A is a factor of B and A is a factor of C, then A is a factor of B plus C. In fact, A is a factor of MB plus NC for all integers M and N. If A is a factor of B and B is a factor of C, then A is a factor of C. If A is a factor of B and B is a factor of A, then A equal to B or A equal to minus B. If A is a factor of BC and GCD of A comma B is equal to 1, then A is a factor of C. If P is a prime number and P is a factor of AB, then P is a factor of A or P is a factor of B. Finding the number of factors of an integer and the sum of factors of an integer. First, make prime factorization of an integer n is equal to a power p into b power q into c power r, where a, b, and c are prime factors of n and p, q, and r are their powers. The number of factors of n will be expressed by the formula p plus 1 into q plus 1 into r plus 1. This will include 1 and n itself. Finding the sum of the factors. First, make prime factorization of the integer like above. N is equal to a power p into b power q into c power r, where a, b, and c are prime factors of n and p, q, and r are their powers. The sum of factors of n will be expressed by the formula a to the power of p plus 1 minus 1 into b to the power of q plus 1 minus 1 into c to the power of r plus 1 minus 1 by a minus 1 into b minus 1 into c minus 1. GCD and LCM. So GCD stands for greatest common factor or divisor. The greatest common divisor, also known as the greatest common factor or highest common factor of two or more non-zero integers, is the largest positive integer that divides the numbers without a remainder. To find the GCF, you will need to do prime factorization. Then multiply the common factors. Pick the lowest power of the common factors. Every common divisor of A and B is a divisor of GCD of A comma B. So A into B is equal to GCD of A comma B into LCM of A comma B. Lowest common multiple. The lowest common multiple or lowest common mul- multiple or smallest common multiple of two integers A and B is the smallest positive integer that is a multiple both of A and of B. Since it is a multiple, it can be divided by A and B without a remainder. If either A or B is 0, so that there is no such positive integer, then LCM of A comma B is defined to be 0. To find the LCM, you will need to do prime factorization. Then multiply all the factors. Pick the highest power of the common factors. Coming to factorials. Factorial is of a positive integer n, denoted by n factorial, is the product of all positive integers less than or equal to n. For instance, 5 factorial is equal to 1 into 2 into 3 into 4 into 5. Note that 0 factorial is equal to 1. Factorial of negative numbers is undefined. Trailing zeros. Trailing zeros are a sequence of zeros in the decimal representation, or more generally, in any positional representation of a number after which no other digits follow. 12 trailing zeros. The number of trailing zeros in the factorial, the factorial of a non-negative integer n square plus n by 5 cube plus so on plus n by 5 power k, but k must be chosen such that 5 power k less than n. Let's look at consecutive integers. Consecutive integers are integers that follow one another without skipping any integers, like 7, 8, 9, or -2, -1, 0, 1. Sum of n consecutive integers equals the mean multiplied by the number of terms n. If n is odd, the sum of consecutive integers is always divisible by n. If n is even, the sum of consecutive integers is never divisible by n. The product of n consecutive integers is always divisible by n factorial. Evenly spaced set. Evenly spaced set or an arithmetic progression is a sequence of numbers such that the difference of any two successive members of the sequence is a constant. The set of integers 9, 13, 17, 21 is an example of evenly spaced set. Set of consecutive integers is also an example of evenly spaced set. If the first term is a1 and the common difference of successive members is d, Then the nth term of the sequence is given by an is equal to a1 plus d into n minus 1. In any evenly spaced set, the arithmetic mean or average is equal to the median and can be calculated by the formula mean is equal to median is equal to a1 plus an by 2, where a1 is the first term and an is the last term. The sum of the elements in any evenly spaced set is given by sum is equal to a1 plus an by 2 into n, or sum is equal to 2a1 plus d into n minus 1 by 2 into n. Sum of n first positive integers is equal to n into n plus 1 by 2. Sum of n first positive odd numbers is equal to 1 plus 3 plus so on plus an is equal to n square, where an is the last nth term and given by an is equal to 2n minus 1. Sum of n first positive even numbers is a1 plus a2 plus so on plus an is equal to n into n plus 1, where an is the last. If the evenly spaced set contains odd number of elements, the mean is the middle term, so the sum is middle term multiplied by the number of terms. There are 5 terms in the set 1, 7, 13, 19, 25. Middle term is 13, so the sum is 13 into 5 is equal to 65.